Good afternoon, everybody. So today we will be starting with our next practical experiment, and that is to prepare para-bromo acetanilide from acetanilide. So in the first experiment, we prepared para-nitroacetanilide from acetanilide. So in this second experiment, we will be doing the preparation of para-bromoacetanilide from acetanilide. So we will be using here green chemistry approach. So in this case, we will be using ceric ammonium nitrate and potassium bromide as a brominating agent. Otherwise, if we do normal bromination reaction, in that case, we use bromine in some chlorinated solvent. Either we can use chloroform or CCl4. So as the handling of bromine is very difficult, so in this case, we will be using the green chemistry approach to do the bromination of the acetanilide. So in this case, we will be needing ceric ammonium nitrate, potassium bromide. Moreover, this reaction is carried out in aqueous solvent. So we will use here water, so we will be using here water, and also we will be using ethanol. Right? So let us do the reaction involved in this case. So the chemical reaction here involved is, so we will be taking, what happened here? Okay. So we will be taking here acetanilide. So this is your acetanilide, right? So since we want this para-bromoacetanilide, so means at the para position, we will be needing bromo, CuCH3. So normally we use bromine as a source of bromo. In glacial, we carry out the reaction in glacial acetic acid. But as we are using the green chemistry approach, so in this case, we will be using ceric ammonium nitrate plus KBr, which will provide bromine, Br positive. So that Br positive will react with this acetanilide. So let us see the mechanism of this reaction. So they like the nitration. So in this case, the electrophile is Br positive. So this is your acetanilide. Nitrogen is having the lone pair. So in this case, this lone pair can go here and we can draw the resonating structures like this. So double bond NHCOCH3 positive. And here we have negative charge at ortho position. And in the next resonating structure, we will be having the negative charge on the para position, CH3 positive. And further, another resonating structure in which we will be having, excuse me, this is this. So in this case, double bond comes here, negative here, double bond NHCOCH3 positive, right? So now your Br positive generated from ceric ammonium nitrate can either attacked by this ortho, or there might be attack at the para position. So two possibilities will arise. So in one of them, we will be getting if the attack at ortho position occur. So this is formed. Once we get this thing, COCH3 positive, and here Br is attached. So this ortho product is formed. And in the next step, this step attack is slow step, and in the fast step, we will be having, so here we have H. So this H positive will leave, and we will be having, in this case, the product, this ortho substituted para-bromoacetanilide. So if the attack occur at the para position, so this step is again slow step. So in this case, we will be having this HBr. And in the fast step, there is removal of this H positive. This double bond goes here. And we will be having this Br, double bond, NHCOCH3. So this is para product, right? So when we use ceric ammonium nitrate, and KBr combination, in that case, we will be getting only this product exclusively. So in this way, you can write the mechanism of this reaction. So next is the procedure to carry out the practical. So first what we will do, we will dissolve. The first step is to dissolve 1 gram of acetanilide in 15 ml of ethanol, which is taken in conical flask, right? Then we will take a separate conical flask, and to this we will add KBr, and we will dissolve this 1 gram of KBr and 6 gram of cetic ammonium nitrate, which I am abbreviating as CAN, in 15 ml of water. Then after this, we will add this cetic ammonium nitrate and KBr solution slowly to the beaker, to the conical containing acetanilide. Okay. Lide. Then after this, what we will do when the addition is complete, we will stir the reaction mixture using glass rod for 10 minutes at room temperature. Then after this, we will pour this reaction mixture on crushed ice. Crushed ice. And after this, we will keep it for 10 to 15 minutes, or you can either use crushed ice or ice cold water. So both of them can be used. And then after this, you will be getting a precipitate, and then filter these precipitate through Buckner funnel, as we did in our first experiment, right? And then dry the PPTs and note down their yield and melting point. So this is our experiment. So these are the steps to carry out the experiment, right? So this is the brief procedure. So now the one question is, why we are using cetic ammonium nitrate instead of bromine? The answer is the bromine is very corrosive in nature. So moreover, when we use bromine in acetic acid or chlorinated solvents, so we have to use organic solvent. But when we use this cetic ammonium nitrate and KBr combination, we will be using aqueous solution, water, green solvent, right? So the reaction, moreover, the reaction in this case is fast, and also it will yield para product in high yields. So these are the benefits of carrying out the reaction using the green chemistry approach. So these are the instructions for practical examination. I hope you understand all these. So thank you. So I will stop here.